Hello, hello. Just gonna test the stream real quick. See if it's all good. Alright, everybody. So welcome back to another stream where our goal is to learn GameMaker Studio and specifically learn stuff related to Project Amaranth to try to get new programmers getting into our programming team. So today we're going to be going over collisions and just general positioning, velocities, collision masks, that kind of stuff. And in the end, our goal is to create the collision system that Project Amaranth itself uses. So, just some preliminary stuff. We're going to want to create a room. I'm going to just do room test area. I'm going to use the same width and height that I used for Project Amaranth. And then room speed is always 60 FPS. And then we're going to create some objects. Just to start off, I'm going to create a sprite. I've got a wall. And I'm going to make that a 32 by 32.
Anyone in the stream right now?
I don't know.
Oh, okay.
It says we're streaming, so I think we're good.
Okay, let me go ahead and check.
Yeah.
I'm not sure if that mic can pick me up. Hopefully it can.
Probably. We'll go ahead and create just an easy wall. And just a circle, just for testing. Preliminary stuff, not really necessary that you understand. I mean, you should be able to understand what we're doing here, but okay, so first things first. So every object has an X and a Y position. So if I put my mouse on the screen, you can see on the bottom left here, on the bottom left we have our position in the room via where the mouse is. So if I start placing an object, and I'm just going to create one, that object is going to have an X and a Y location. So these are just default variables that objects have. We went over this a little bit in the last stream, talking about positioning and velocities. So just to recap, there's 6 different variables related to movement or positioning. You have your X, your Y, your H speed and V speed, and your speed and direction.
Audio test.
All good?
It'll happen eventually.
So X and Y denotes position, and all of these don't determine the actual velocity they're going. And I would say there's a difference between these two and these two. If you remember H speed and V speed, H speed is your horizontal velocity, and your V speed is your vertical. Okay. So depending on what you do with your coding, you're going to either use H speed, V speed, or speed and direction. You don't typically intermix the two, because your speed is a combination of V speed and H speed, and direction is which direction you are currently moving at that speed. So for the most parts, we're going to just be using H speed and V speed. The last time we used speed and direction because it was just easier for the bullet, because you could say, hey, move this direction at that speed. But with...
Real quick, enhance the mic audio. It's a bit low.
Okay.
Oh,
Hey.
we'll see eventually.
Just get a little closer then.
Other way. If you want it closer to your...
That might be better.
My fault too.
Yeah. Okay. Is this better, LG? all good? Okay. So these are the basic default variables that we're going to be messing with today. And the reason I'm saying we used hspeed and vspeed more for collisions is primarily because you're going to collide with the left side of things, the right side of things, the top and the bottom. You don't typically have a collision like at a corner. You don't like check for that normally. You only check for the different sides. That's why it's a collision box and not like a collision circle. So anyways, in this case, that's what we'll be using, hspeed and vspeed. But first I want to go over some of the... Okay, one thing I forgot to mention. So in GameMaker, there's 3 different events for step. And if you recall, step means frame. So that means every frame these events are running. It goes begin step, step, end step. If you set some velocity in here, so let's say v speed is equal to 5, and you have an x, let's just say you have 2, the v speed gets applied between step and end step, so between these 2 events. So if I check for my position here, it's going to be different than my position here. So it's just something to note, and it's kind of a key fundamental thing about GameMaker that you will need to learn. It's like when events happen. It hits the step every frame right after the velocities are applied, and then end step goes. Okay, so let's talk about collisions. And let's just make an example first of all. I'm gonna create a wall object. Object wall. And it's going to have the sprite wall. I'm just going to place that in the room. This object, and this is all for example, it's just going to be a object mouse or object test. So object test is going to have some code. So again, the first thing we're going to learn is collision line. So collision line requires like a lot of the parameters. You can see them all down here. So you're going to start at some point and end at another point. So I'm going to do mouse x, mouse y, and then my second point will be mouse x plus 50, mouse y, and I'm just going to leave them the same. So once you got your position down, you're going to set which object you're looking to collide for. And in my case, we're going to do object wall. Precise versus not precise, just leave that 0 for now and not me 0. I'll talk about those 2 in a second. I just want to show you this for now. Because I put my X position and Y position based on the mouse, it's going to move based on where my mouse is. I can visualize this with a draw event if I wanted to. So let's say draw, there's a thing called draw line. So I could do draw line, I'm going to put in the same coordinates. And I'm going to say if there is a collision, I'm going to make a variable for that. Collision equals false. And then we'll say every step it'll set collision to false. But if there is a collision, we'll say collision is true. So if we go back to our draw event and we say if there's a collision, we can say draw set color C green, else draw set color C red. So now that should give us a good estimate for if there's a collision or not. So here's my visualization of where the collision is. And as soon as I touch that, it turns green. So all along that line, it's red until I touch it. So that means no collision, collision. So I could change, for instance, if I wanted to set a different position, I could do positive Y for my mouse instead of X. And this is just kind of an example to show the fact that it's a line, I guess. Like it's not just set in that one direction. So now it's vertical line. So the kind of interesting thing about precision, if we look at collisions, this is what it means by precisions. So every object has its own collision box, and it's either this entire square, or if you want to say precise, then it's the actual sprite. So in this case, even though this box is not touching this blue one here, it's still colliding with it because it's an imprecise collision. Versus this object here, it's not colliding because the collision check is precise. So even though it's hitting the corner, it's not actually colliding with the object. So precise collisions make it precise, but it also is slower. And in this case, we're looking at walls, which are 32 by 32, and we don't need to make precise collision checks with something that's already a square or a rectangle, something that's rectangular. So that's why we set it to 0 or false, either way. And then not me we set to false because we're not checking for itself. If I were to make a test that was supposed to collide with this object that I'm currently coding in, then I would say, no, it's not me. Sorry, if I want it to collide with itself, I set it to false. But since this object, it's testing for a different object, which is object wall, it doesn't matter if we set it to false or true. False is default because there's less processing. If it's set to true, it has to basically erase the current object from memory, in a sense. That's a bad way to put it. It has to do an extra check to make sure that it's not the same object. So we just set it to false by default. And you're pretty much going to set it to false for like 99% of collisions. So that's object line, or collision line. I wish I had other people here. Here, does that make sense to you, since you're watching?
Sorry,
Everything I was saying?
I was sending an email, sorry.
Oh, so you're not paying attention?
Well, not right now.
So, this is collision line,
Alright.
and I'm setting its position to be where the mouse X and Y is.
Alright, and then mouse Y plus.
Yeah,
50.
so it's just a
stick.
vertical line.
Okay, a stick.
Yeah. So I was testing that and showing that like this is what the collision looks like.
Yeah.
And when I collide over, it turns green, just showing that,
Yeah, that
yes,
makes,
there's a collision.
that makes sense.
Sweet. It'd be helpful though if you watch with me, because I don't know 100% of the time like if I'm making sense to people.
Yeah. I just had to send this email, sorry.
Okay.
I'll just be done with it.
Yeah. Okay, so there's obviously a lot of other types of collisions other than just collision line. We can do collision rectangle, which plain and simple makes a rectangle. Cool part is we can keep everything the same, and instead of drawing a line, we'll draw a rectangle, and we'll give it the same coordinates, x plus 50, y plus 50. Rectangles, when you draw them, they want you to specify, do you want only the outline or to fill it in? We're going to do fill, so it's going to be false for outline. And testing again. And collisions. So basic collisions. It's pretty cool stuff. Just one more for, just in case you have questions, we have circles. And then we're going to draw a circle. So with circles, we have an X, a Y, and a radius. So I'm going to do mouse X, mouse Y, and then a radius of 50. Same with drawing circles, X, Y, radius of 50.
Just have to get that out of the way.
And plain and simple.
There we go.
Collisions. You'll notice that even though it's imprecise, the precision only applies to the other object. It's still going to do a collision in a circular pattern. Like what I'm trying to say is the precise here. The precise variable only applies to the object it's colliding with.
Okay.
Okay, so that's your collisions with shapes. I wonder, what are the other shapes we got? The other shapes are ellipses and points. So points is pretty simple. It's just a point, a singular point.
Yeah.
We could do that one, I guess, real quick. I'm gonna just keep it as a circle, but like true. So this is gonna draw a circle with no fill because the outline is set to true. And this is going to do a collision point, X and Y. Oops. So it's going to be exactly where my mouse is. And so if I touch it, it turns green. So this is collision point. The circle is just representing, like, do I have a collision or not, since I can't really draw a point without seeing it. There's not really enough pixels. You could, if you wanted to, do draw point. Draw point. It is a thing, but like you're not going to use that for the most part because it draws a single pixel. So those are the main collision functions. There is other types of collisions though, and these are place meeting and these place functions in general. The main one though we use is place meeting. So what place meeting does, which is really cool, is it checks, does my collision box collide with another object's collision box? So instead of just testing a line, a circle, or square, or whatever, I'm literally checking collision box to collision box. Yeah. So let's give object test a sprite. How about the circle?
So if you were to instance have like two car sprites and you had them check the collision box of the other, you basically could have a sequence, basically check if are you colliding with another car? If so, have both of them be damaged or whatever.
Yeah.
Oh, okay.
Yeah. I'm gonna give the test object here the circle, and then we're gonna test for place meeting. We're gonna get rid of all the rest of that stuff. So place meeting only has 3 different parameters. Its location and the object you're checking for. Location, I'm going to just do X and Y. Really what this means is it's going to check the collision box in this place the sprite currently is, or the object currently is. If I wanted to check somewhere to the right, I would do X plus 5. Somewhere to the left, X minus 5. Pretty simple. And then let's do object wall. So now instead of this, I guess we can keep this here so you can test if there's a collision still. But the X and Y position for this mouse needs to update. X equals mouse X, Y equals mouse Y. So now we can move the object around using the mouse. Where is my object? Oh yeah, I need to, okay. You might remember before in the other tutorial, if you have something in the draw event, it won't draw the sprite. So if you want to do that, you would do draw self. So it just draws whatever you put in the sprite section here. Okay. So now we'll see it collides via the two objects colliding. And if you notice, it's colliding right here even though the objects aren't really touching, and that's because of what's called masks. So even though this object is a circle, its mask is a square. And you can look at that if you open up the sprite. There's a thing right here, modify mask. And you'll notice the entire sprite is black, which means the whole sprite is what's using collisions. You can actually update that here. You can say, okay, precise collisions, or I could do diamonds, ellipses. In this case, I'm just gonna do precise just for testing.
Now, what's the advantage of having a precise over a rectangle, or like having a rectangle over a precise?
Processing speed.
All right.
With rectangles, it's easy processing, but with precise, it has to check individual pixels. So it's got to do a lot more checks for precise than any of the other diamonds or whatever. So if I did precise and I ran it again.
Now, obviously, we're working at very small scale here, so there's going to be no lag.
Yeah.
But bigger games like ours might actually, well, maybe not even ours.
Yeah, with ours, we still use rectangles for most things. Especially with how our collision system works. But anyways, you notice now that it's not actually colliding anymore. And that's because we changed that hitbox.
Cool.
Yeah.
Now,
All right.
Now you did mention that both have to be colliding in this sense.
Yeah. Well,
could you give an example of it not being the case, like where the circle is outside that big circle, or not necessarily outside, more like outside, so that you can somehow collide it with the black square at the same time, but show that if you don't do both, then
like if I didn't set precise for like the wall, like if the wall was a circle or something.
No. More like having the circle on the inside be like outside, but like close enough to the big circle, so that you can collide both of them with the rectangle, but only collide. You can also collide one of them with it. Because right now you're colliding both of them with it automatically.
No, the big circle is just showing is there a collision or not.
Oh, okay. So okay, the circle.
Perhaps I should instead of drawing a circle, I could draw text. I could do mouse X. And I'm gonna put it like below the mouse somewhere. So X plus, how about 100? Or actually, let's just put it in the top left corner of the screen. So that's 100, 100, and I'll say collision plus string collision. So that's going to return true or false, and then it'll update that up there. Whew. So now it doesn't draw the circle, so it's a little less confusing maybe. It's not just this collision. Boop, boop. 0 for false, 1 for true.
Yay. That works.
Boop. Just to show something real quick, if I had it as a circle for my walls, you're gonna notice the actually hold on, we'll see if this actually makes sense. Okay, so since both objects are precise in here, then that's why they work like that. Since they're both precise, it's gonna check like that. Okay, well I was just trying to think, what's the point of, oh, it's because it's place meeting. I was thinking, what if I still had collision rectangle and then did precise? Here, let's do that real quick. I'm just gonna comment out this code. So if I'm gonna go back to collision rectangle real quick. Mouse X, mouse Y, mouse X plus 50, mouse X plus 50. Object wall, precise. I just want to look at the difference between precise and non-precise. And false. And then I'm going to copy this over here. So instead of drawing the text, instead of drawing self, Just gonna draw that rectangle again. Draw rectangle. And then we're gonna do false here. So this is with imprecise collisions, and I haven't actually tested. Whoa!
What is going on here?
I made mouse X in the Y position.
Oh. That was weird.
Yeah, you can do some really cool stuff with GameMaker. Anyways. So yeah, here's the thing. Since we did imprecise collision checks, it still collides even though the mask for this is a circle, or it's precise anyways. It's still using it as if it was a rectangle. So that's your big difference between between the collision functions and then just like checking masks. Boop. Even though it's not colliding, it's still colliding. So in order, if you wanted to fix that, you would just set precision to be true. And that would get rid of that.
Hopefully.
Yeah. Yeah, there it goes.
Yeah, that works.
Okay. So what is next on the to-do list? So we did lines, demonstrate with mouse. Yeah. Okay, yeah, masks.
You should check it. You should check mark it as you go along, so you don't forget your place.
True, but I don't care.
Okay.
So masks is something I want to talk about next. I'm gonna go ahead and get rid of most of the code we have, except for the collisions. Actually, place meeting I'll keep. I'm trying to think about it. So I want to talk about certain things. I want to talk about SpriteIndex, MaskIndex, image X scale, and image Y scale. You might have noticed when we were drawing ourselves, we were drawing the sprite circle up here. This, when we set it, is what's being set as the sprite index. So we can actually change that via code using this. You could set it to sprite wall instead, and it would instead change this from a circle to the square that we have as the wall. But what's cool is you can actually change the collision box to not be associated with the sprite by actually setting the mask index to be something else. So I could pretend that the sprite is a wall, but I could say the collision is the circle. And I don't know why I would want to do that for this case, but but I mean, it's something you could do. And this is very common for pretty much anything, for any video game character, because a lot of times, like, your character will have animations, but you want it, like for Amaranth, you want the collision box to be a square the entire time. So like in our game, it would be like sprite collision box 32 by 32 or something. But then the sprite index would be constantly changing for animations. The interesting thing about this, I'm going to set them both to sprite wall, is you can update the collision box by updating image X scale and image Y scale. So if I set these to 2, that's 2 times the length, 2 times the height for your collision box. Since we're using wall, and we're drawing, let's draw self. So let's see. So we still have the place meeting in here for the wall, so it should all work out. So we're using sprite wall and sprite wall for both the collision and the whatever it's called, the mask. And I forgot to put in the I'm gonna put the draw text back in there. I don't know why I got rid of it. 100, 100, collision, the string, collision. Huzzah! So it's using place meeting for our collision in this case. So even though the sprite is actually like half the size, we've updated the mask to be bigger and the sprite to be bigger. So image x scale, y scale is updating both the sprite index and the mask index to be 2 times as big. And just to show that there's a difference here, I could do sprite circle for my collisions, which will make this really dumb, but you can probably guess it won't collide in the corner anymore because the collision mask is a circle. So you gotta imagine there's a circle in the middle of there that it's colliding with. And that's why these corners aren't colliding. Does that make sense?
Yeah, of course.
Pretty interesting stuff. For Amaranth, a lot of times we don't use SpriteIndex. We will use draw sprite. So in this case, draw a sprite, and I'm going to use sprite circle. Subimage. So if a sprite has multiple images, like in this case I can make it more images and like create an animation. These are called subimages. So subimage 0, subimage 1, subimage 2, subimage 3. In this case there's only one image, so we're going to say 0. Where'd it go? Right here. So image 0, which is the first one. And then we say X and Y, so mouse X, mouse Y. So now, the interesting thing, it will still draw myself unless I get rid of that. So since I'm replacing my sprite index with an actual draw event here, or draw code, I'm just gonna get rid of draw self. We don't need that anymore. So no matter what I set sprite index to, it's not gonna matter anymore because it's not even drawing that, it's just drawing a separate sprite. So this is really helpful because now I can set, if I wanted to do different, let's say X scales and Y scales for your sprite, it's not going to be tied to your mask anymore. Because I can see, like, this is still going to draw the square, or I guess I did circle, but my mask is still 2 times as big. So if I play it out, I have the small circle, but you'll notice the mask is still really big. So this is really handy because I can make the sprite anything I want now, and I can update the size based on code here, and then I can update the collision mask separately from the sprite, which is what we do in Amaranth. We have a function that we created, which is just like set mask extent, I think, and you basically put in what mask you want, this, and then the X scale and Y scale, and it basically just does this. It sets it what mask you want, what's the X scale and the Y scale, and it just basically works for every object that you want. Does this make sense?
Yeah, of course.
Okay. So it's already 5:30. And I think we understand enough about this to create our platformer. I'm going to set up the game a little bit more like Amaranth. I'm going to get rid of first this. In Amaranth, we have multiple walls. And so we have one object called parent wall. Plain and simple, it's a parent is... Actually, I probably should give an example because this is important. For example, in this object wall, we can set its parent to be parent wall. So that means anything in parent wall, if I change the code will be the same in object wall because it's parented. So, for instance, if I have some object which will be our player, and I say check for check for if you're meeting, if place meeting, and I just say X, Y, and I say parent wall, this parent wall is going to check for both parent wall and object wall, because object wall is technically parent wall, because it's parented. So I can create any number of walls, and as long as I check for a parent wall, it's going to check for every single wall. It makes sense. So anyways, for now though, we just have one wall, so I'm just going to leave. Actually, we'll keep it as object wall. I'm going to set this to no sprite because it doesn't matter. So object wall has its own sprite and its own collision. So that's good. I'm going to go ahead and make a test level real quick, just so we have something to test it on. What is this? Parent wall? I don't want that anymore. I'm going to hold Control and Shift, just create a little flat ground. Whoop. And create wall and supply forms. And then let's create our object player, just plop them there. Just for our testing purposes, I'm going to make the player have a square collision box as well. And in Amaranth, it pretty much is the same collision box. I just don't want to draw a sprite for it yet. I guess I could make a separate color for it at least, so it stands out. Let's make it blue. Blue's a cool color. So now we have sprite player. So now I'm gonna set sprite player. There we go. Okay, so now we have a player. Doesn't do anything yet, but that's what we'll put in. So let's see. So the first thing we want for a player is gravity. So gravity is pretty simple. We're gonna do in GameMaker, y is downward, so we're gonna say v speed plus equals, I don't know, 0.5. So again, v speed is its vertical velocity, and we're gonna say it's gonna increase by 0.5 each frame.
So accelerate.
Yeah, basically that's what it means.
And instead of per second, it's per frame.
Yeah. So let's test it out real quick.
Which is at what frame per second?
60 frames per second.
Is that what its default right now?
Yeah, well, the default for GameMaker is 30, but we always set it to 60. Cause
okay, is that what it is right now?
Yeah.
Okay.
So, 0.5 seems like a small number, but because we're going 60 frames, it's updating really fast.
Yeah. Don't end up putting like 9.881 at like meters per second, because it's not going to be 9.8 meters per second. That's like the gravity constant for those who do not know.
Pew.
And you're already gone.
Yep. Anyways, 0.5. So the next thing we need to do is
detection of walls.
Yeah. So we want that to be after we set the velocity. So let's say we'll do collisions as the title of the collision. Yeah, collisions as the title of the script. Let's say collision with ground. Now you might think it would be easy to just do collision how about collision line? And let's say, ooh, I just thought of something. In Amaranth, we use the center of the object, which would, in this case, would be 16, and then the very bottom. So our center point is here. So this is -x, +x, -y up here, or the height.
Why is that an important thing to know?
So this is important for, it just makes detection a lot easier in many cases. And it's important to know because when we test collisions, like collision line, we're detecting based on the x and y position, and the x and y position is right here. Or at least it is now because I set the center there. So in this case, if we're detecting for something under, you would think maybe x minus 16, y plus 1, x plus 16, y plus 1. So this would create a line that's x minus 16 and then 1 lower, so like not colliding with this object, but so it's checking under. And then plus 16, so that creates a line from here to here.
Oh, okay.
What's funny is that I'm trying to lead to a point where it's like, well, this is kind of pointless. This is how I learned it at first, though, is you use collision lines and you say parent wall precise false. It doesn't matter because the object wall is already a square, so false. And it's not like we're colliding with ourselves, so we say false as well. So if there's a collision there, v speed is 0. Now there's a lot of things wrong with this, but it would technically work in our case.
The first thing wrong with it is that it's only detecting the bottom, isn't it? Wait.
Yeah, it's only detecting the bottom. That's all we care about right now. And you'll notice it's slightly above the wall.
Yeah.
And that's because, well, first of all, it's because it's detecting one below. If I got rid of the +1, it would look better. Or should anyways. Ah, but see, here's the problem. It went through the wall. And that's because on one frame it was above the wall, in the next frame it added the h speed, or the v speed, and so it's teleported down here, then checked for a collision. So what you need to do is, in this case, you would do plus v speed and plus v speed, because now it's checking where is it going to be in the next frame. Boom. Now it's above. I don't know where I'm going with this. I was trying to get to a point where it's like, okay, using collision lines is kind of pointless.
So just go ahead and just.
I'm just going to show you the real way you should be doing this. Because
that's just not the right way you should be going about it.
Yeah, this technically can work, but it's more convoluted than it needs to be. We can just use place meeting.
Oh.
And x plus y plus v speed.
So what does place meeting do?
I already went over this.
Okay.
So place meeting looks at the current collision box and sees if it collides with the other collision box. So v speed equals 0. So the same collision that I just wrote can be rewritten to place meeting. And place meeting is just way more efficient. So instead of having to say, oh, our x and y is so and so, we can just say, okay, this whole collision, see if that collides with the other object. We don't have to specify how big it is, because place meeting already specifies how big it is, because it's using the mask.
Oh, real quick, if you make v speed like negative, would it project you backwards at like a bouncy wall? So like I noticed that.
Oh, if I could set this to, yeah. If I did this, it would.
It would bounce up and down like a bouncy ball.
Because it would collide and then the velocity would inverse. Boing boing.
Yay!
Fun with programming.
I knew it.
Okay. Anyways.
I imagine you can also do v speed times 0.5 just to ensure that every time it bounces, it gets lower and lower.
Yeah, and
however,
this is exactly how bouncing works.
However, that does mean though that at some point it's just gonna bounce infinitely, isn't it? Like really, really quickly. To the point where we'll no longer be able to see it, but it's still processing that. Yeah. So at some point you might have to say at this point.
Yeah,
stop.
if your velocity is between like negative 0.01.
If it's kind of ridiculous, just stop.
Yeah. Anyways, back to collisions. Back to stopping, because that's our ultimate goal, is to stop. But you'll notice with the current setup, it's not going to be precise. It's always going to spawn like slightly off the ground. Okay, it just happens that it worked for that case. But let's say if I put more players in here at different various heights, I'm going to hold Alt. So now it's at a kind of a weird height.
Good thing they don't collide with each other.
Yep.
Right now we just have water molecules.
This is interesting. This just happens to work because after it hits stop, the velocity from gravity pushes it back down again. This is an imprecise collision though, but let me try to show you why. show message. In GameMaker, you have show message and show debug message. And I showed this earlier in the basic tutorial. So show message is going to pop up a message that freezes the game.
Oh, okay. So this is gonna basically show a message every time it hits the it does this, it runs this piece of code.
Yeah.
Which you'll see a lot of.
Yeah. So basically, it's going to tell me when there's a collision. So there's a collision there, and you'll notice collision, collision, collision. So if you notice, it was slightly above before. Let me try to get a better example. I'm gonna put it like way up there.
You guys get more velocity.
Yeah. Because I'm trying to show that you see how it collides right here, even though it's not touching. Which it's good though, because you're saying that in the next frame it is going to collide. So we're testing it before the collision actually happens. And the reason this is good is because we can then make a calculation that says, hey, align yourself with the wall. Currently it collides and it just floats there. V speed is 0 now. And if I let it go again, oop, where'd it go? If I let it go again, the gravity is going to take over and collide again.
In this case, it just happens to work very well.
Yeah. Here's a situation where it wouldn't work. If instead of having gravity, let's just say
a consistent V speed?
or like right when it spawns it has a velocity.
Oh, okay.
So this is more for like left and right collisions, but let's just say it starts with a velocity. We're in 0 gravity now. So it moves down. Okay. Well, it just happens to be that it's really close. Let's give it a really high velocity. How about like 100?
So in a scenario where there's no gravity, it makes it difficult. So it essentially doesn't really. Oh, you still have to test thing.
Yeah. Well, it's good. Okay. Let's see now that I hit OK. It's not aligned with the wall at all. Yeah. Let me get rid of the test thing.
At higher speeds, wouldn't this be a lot more exaggerated as well?
Yeah, it would be more exaggerated. So the thing is yes, we want to collide there, but we want to move the player to where it's touching the wall now. Let's see. Yeah, get rid of this test. Yeah, it just so happens that it works better with velocity because then, yes, it collided there, but then now gravity's gonna take over again. So in order to fix this, there's a line of code. Oops. Oh god. There's a line of code that we're gonna put in. It's gonna be while there's not a collision. And here's the interesting part. We're gonna do x, y plus 1, parent wall. And then we're gonna increase the y position until there is that collision. So what I mean is that, yeah, it's gonna first check that collision, and then it's gonna move the player down until it's right next to the wall. So if I test it out, boom.
Yay.
Yay. So if you look at this code, you understand what it means.
Yeah.
But
it's a wild. I do MATLAB.
That's true.
Real question though. God dang it! What was I gonna ask? Oh, if a coder sees that it works, like you saw it before, that it just so happened to work, even though it's like, because if you saw that the velocity just stops if you get close, so without any gravity it would be crap. But in that scenario, it happened to work. Would you advise them to still do this, even if it worked? The first
no. You may not notice it at first, but let's just say I add jumping into the game, which let's go ahead and do. You'll definitely notice it. Let's see, gravity. Gravity's on. I'm gonna get rid of the initial velocity, which I
think
guess
it'd be a lot more exaggerated on whenever you're jumping at something. So like from the bottom up.
Yeah. So first of all, we have collisions. Let's see. Okay. Jumping. So let's say if place meeting x y plus 1 parent wall. So this is saying if there's ground below you, then and if and keyboard check VK space. So if there's ground below you and you press the space bar, we're gonna set a velocity. V speed equals how about -10? And this actually should be, yeah, collision check is fine. So if we run this, it's gonna look weird. Oh wait, we need to go back to the weird collisions, because this is perfect collisions already. I'm trying to demonstrate it a little bit. You'll notice it kind of like bops there. Just happens to be at a perfect gravity again. 10.1 or something.
We're not like setting this up.
It just happens to be. Yeah.
Oh, well, there we go. I saw something.
Yeah. You see how it kind of like bumps? That's kind of jarring.
It's the equivalent of like falling in a very slight quicksand.
Yeah. So that's why we use perfect. I call this perfect collisions.
Now, is there more processing power when using perfect collisions?
Yeah, it's definitely more processing.
Is it like?
But it's like needed.
Needed, and like, is it like ridiculous amount of?
It's not ridiculous, and the reason it's because place meeting is way more efficient than collision line. I don't know why, it just is.
You heard it here first. You heard it here first. It's just more efficient. I don't really know why.
I'm gonna set to -20 just so I get more jump into there.
Yeah, because you need to be able to land on that secondary platform.
Yeah. Boop. Wham. Okay.
That's pretty good.
Yeah. So here's an interesting thing. I'm gonna put myself under the platform. So what do you think's gonna happen?
He's gonna smack his head on the top of it, but because it's using perfect. Okay.
So here's the interesting thing. So because I'm using the perfect collision, but I'm not checking if I'm moving up or down. If I touch the top, I'm colliding with it, and so it's gonna move me down until it finds the wall again. So I need to do if v speed is greater than 0.
Okay, now I understand.
So if I'm moving down, then check for a collision downwards.
Wouldn't you have to make a separate?
Boop.
Wouldn't you have to also make a separate like thing to check for? Are you hitting the bottom end of the platform?
Yeah.
Unless you wanted it to be like this.
Yeah. So collision.
In which case, I guess you can make a specific type of platform that would have that situation happen.
So yeah, in this case, we're going to do when you're going upwards, so velocity is negative. Negative is up. Then, okay, the interesting thing is this v speed is going to be the same because going upwards, it's negative anyways. So if I said negative v speed, it would still check downwards. So plus v speed is what we need. But then we're going to check one above, and then we're going to move up until we collide with that wall.
Real talk though, if you had it to where you went through the platform, like the without like the second check of being underneath it, but you happen to jump at the right height to be inside the platform, you would essentially be standing inside.
Yes.
Okay.
Yes. And that's why in most of the times you have a platform like that that's 1 pixel long, so that you don't.
Doesn't that make
even then you can still collide with it.
I guess you can make it like 3 pixels just to be sure. But like, I guess like 1 pixel would be too dangerous because then if you're traveling like faster than like 60 frames per second, you might go right through it, or well, not go right through it. That'd be too fast. But like for the sake of argument.
So there's an interesting thing I found recently, thanks to some other people. You can actually combine both of these. So I can get rid of. Here, let me code it in a separate so you can kind of see. Collision with roof and floor. So you know how this v speed is the same for both. Instead of for up or down, I can collide with both. I can check both cases. and I can say while, and so this is the interesting part. There's a variable or a function called sine, and I can do sine vspeed. Sine takes the value and makes it 1, 0, or negative 1. So it basically just checks if it's positive or negative. So in this case, if I'm going upwards, it's going to be negative v speed, which will just output negative 1 here, which is the same here. And if it's positive v speed, it'll output positive 1, which is positive 1 here. So I'm technically still doing the same check without having to do 2 separate checks. And then for here, I can do plus equals sine of v speed. So now I've basically condensed both of these collisions into one collision. That should still work. Boop, boop. And it still works.
Yay.
And so...
To the viewers, we just thumbs up at each other, so... yeah.
So, we want to make a left and right collision now. So, pretty simple. Instead of v speed, we're going to do h speed. And we need it in the x position. Speed. Speed. And so, plus sign will go into the x. X plus sine h speed. And we'll do x plus sine h speed. H speed equals 0. Basically just reversed everything.
Cool.
So we need to make some way to move left or right. So let's do if keyboard check vk left h speed equals -5. If keyboard check, come on now.
Now, I guess it's important to keep in mind that just because you collide with the ground does not necessarily mean you lose horizontal speed, because horizontal speed is a different thing.
Yes.
So you can have it where you retain momentum. That's another thing, though. Horizontal momentum is retained no matter what. There is no friction or air friction.
Yeah. So if I wanted friction, we have the place meeting here. I'm gonna split this up to be like inside. Since we're already checking if there's ground, we can just say, hey, h speed. Can we do times equals? Is that a thing again? I think so. Yeah.
Yeah.
0.5.
Now you could also have it to where if you're in air, you also have air friction. So
True.
So like else.
Else h speed times equals 0.01 or
Yeah,
0.05.
0.01. Keep in mind, times equals. We're working with here.
Oh, yeah. Then it'd be 99. My bad. Because otherwise, you would just like immediately stop in the air.
Oh.
Yeah, times equals. So we want something close. I'm gonna do 9.5.
Oh, yeah. Now that it's
So now when you're in the air, you kind of retain the velocity. But if you're on the ground, it stops pretty fast. Boop.
So collide with them walls.
Yeah. Eh.
There you go.
Hey,
Don't
we
kill
just
yourself.
made a platformer.
Don't kill yourself or you'll fall into the infinite void.
Yeah.
That which has not been specified. Keep that in mind, folks.
So yeah, this is a basic platformer. Not much code. All works together.
Yeah.
Just for future reference, I'm just going to put this up here. So you have your gravity, your jumping, and your collisions. Collisions should always be your last thing because you're setting your v speed and h speed to 0, which gets applied in the next step. Well, I mean, just in general, if you had it before, you would be doing this.
Now, another question to ask. When you do collisions, do you code the collisions?
That's quicksand. And I'm going through walls.
As a quick question, though, whenever you're creating collisions, do you also create like enemy hitting collisions in there as well, or do you put that in a separate object entirely?
For enemy hitting collisions, like bullets, I usually use collision line, collision point.
Okay.
Depending on the thing. Well, actually, I actually just updated it to use place meeting since that is more efficient.
Well, there you go, folks. Don't use collision line ever.
There are specific times, like let me do a quick example. If I wanted to make a line of sight to the mouse to some other object, let's do it real quick. Advanced tutorials.
Quote unquote.
Here we go.
Quick.
It'll be quick.
Okay, I believe you.
So I'm gonna do what we did before to do just for visualization. You don't have to do this to make collisions. I'm just doing it for visualization. Collision.
Spell collisions wrong?
Probably. Collision. Collision equals false. Just like in Python, you have to set your variables to true or false or whatever default it is before you start manipulating them. Which is why I do that in the create event. Just in like in MATLAB too.
Right.
Line of sight. So if I did collision equals false, if collision line, we're gonna use x, y, and I'm gonna do mouse x, mouse y, apparent wall, precise, not me, there we go. Collision equals true. Draw event. If collision, draw set color, C red or C green. Else draw set color, C red, and then we're gonna draw this line. So this is one way you can just check for a line of sight. Draw a line.
Alright.
Plain and simple. I mean, it's basically the same code for collision lines that I was showing earlier. Oh yeah. We need to draw the player. Draw self. Boop. Well, this is interesting. It's always colliding. It's because the X and Y is like in the ground.
Let's see.
Let's see. If I instead said, how about like the center of the player, so 16.
That sounds about right.
Because remember the height is 32, so if I go up 16, that'll go half the player. And there we go. Now it's in the center. So now this checks, like if there's an enemy over here, I could check, hey, is there a collision with a wall? Yes, so you can't see it. But here there's no collision, so your line of sight is true. So it's a good way to do line of sights.
When using flashlights, this will come in handy.
Yeah.
Eventually. That's an entirely different. Dynamic lighting. Oh boy. If we ever get to that.
Yeah. It's gonna be pain. But anyways, so that's the end of our stream. You should be able to create basic platformers now.
Yeah.
Have fun!